We often write an equation to represent unknown quantities in a given problem. If this rectangular garden has a perimeter of 40 meters with an unknown length and breadth, and we called the length x and the breadth y, then the equation for this would be 2 times the length plus 2 times the breadth equals 40, or 2x plus 2y equals 40. The solution of the equation is all the pairs of x and y values that make the equation true. We can represent this graphically as a straight line. To plot this straight line, we first write the equation with y as the subject of the equation. Then select a few values of x to draw up a table of values. Fill in the y value for each x value. Then plot the coordinate pairs and draw a straight line through them. We've only chosen a few coordinate pairs to plot, but of course there are an infinite number of solution points lying between these that also satisfy the equation. Remember that y and x represent lengths, so the values must be greater than 0. We've shown that these points are not included by plotting these 2 points as open circles. There are many situations in real life that can be represented by a straight line graph. For example, you could say there is a linear relationship between the number of pages read versus the time taken to read them. What is the relationship between x and y? We can describe it in words. It takes Fidel 4.5 hours to read 100 pages. What else can we see from the graph? He reads at a constant rate because the graph is a straight line with a constant gradient. The graph goes through the origin because he has not read any pages at time 0. The slope of the graph is equal to the number of pages he reads per hour, so it is equal to 100 divided by 4.5, which is 22.2 recurring. The equation for this graph is y equals 22.2x. Another real-life graph that shows a fixed relationship between two variables is a conversion graph. This graph shows that 0.45 kilograms is equal to 1 pound. When used to change one quantity to another, it tells us 8 kilograms is 17.8 pounds, or that 12 pounds is 5.4 kilograms. How about this graph showing wages against hours worked? Again, it's a straight line graph, so we know the rate of wages earned is constant. To calculate this rate, we take 2 points on the graph, say 20, 300, and 10, 175. Then calculate the gradient in the usual way. The difference in the y values divided by the difference in the x values is 12.5. The rate at which wages are earned is 12.5 per hour, and the rate is constant. There's something interesting about this graph. At 0 hours on it, the y-intercept shows that there is a fixed starting wage of 50. So, to write an equation for this graph, we know the wages earned are equal to 50 plus 12.5 times the number of hours worked. So the equation would be W equals 12.5 times H plus 50. The friends are getting themselves ready to go for a hike across the mountains. They'll start with an amount of food and eat some of it each day until it is finished. The graph shows how long their food will last if they eat a certain amount of it each day. It starts at 84, so there is 84 kilograms of food at the start and has a negative slope showing the amount of food decreases over time. Its gradient gives us the rate of consumption if we select 2 points on it. For example, 2, 62, and 4, 40. Then calculate the difference in their y values and divide this by the difference in their x values. The answer is negative 11. So if they consume their food at a rate of 11 kilograms a day, the graph will reach the x-axis between 7 and 8 days, at which point the amount of food is 0. We conclude the graph shows they start with 84 kilograms of food, eat the food at a constant rate of 11 kilograms a day, and finish the food during the 7th day. The equation for this graph would be amount of food is equal to 84 minus 11 times the number of days. Or F, for food, is equal to negative 11 times D, for days, plus the constant 84. A travel graph shows changes in position, distance, or speed over time. This one shows the distance hiked between 10:30 in the morning and 12 noon. Remember, the increase in the height of this graph tells us the distance covered is increasing and not that they are moving uphill. They could be climbing, going downhill, or walking on level ground. They started their hike at 10:30, but the graph is flat with the gradient of 0 for the first 15 minutes, indicating there is no change in distance and they had been standing still. At 10:45, the graph starts to increase, and the gradient is constant until 11:15. If we calculate this gradient, we see that they covered 4 kilometers in 30 minutes. The gradient actually gives us their speed, which is 8 kilometers per hour. Then, for the next 15 minutes, there is no change in distance. Our hikers are taking a break. At 11:30, the hikers start off again. For the next 30 minutes, they cover another 2 kilometers. You can see that the graph is less steep here. Their rate of travel is slower. The gradient is 4 and their speed is 4 kilometers an hour. At the end of the hike, they have covered a total of 6 kilometers. Sometimes you will see more than one linear graph on a set of axes. 2 linear graphs will always intersect at one point unless they are parallel to each other. This point is a solution to the 2 equations because it gives us an x value and a y value where the 2 equations are both valid. Here we see that the point -2, 1, is the point solution to both of these linear equations. We need to find a point where these 2 equations are both true. Y equals 3x plus 8 and y equals 6x minus 1. To sketch the graphs, let's find a few values to plot for each equation. For the equation y equals 3x plus 8, some sample points are 0, 8, 1, 11, 2, 14. For the equation y equals 6x minus 1, 0, -1, 1, 5, and 2, 11. Plot the points for y equals 3x plus 8 and draw a line through these points. Then the same for the equation y equals 6x minus 1. And the coordinates for the point where the lines overlap is 3, 17. So both equations are true when x equals 3 and y equals 17.